Love is a burning thing. It makes a fiery ring. Found my wild desire. I fell into a ring of fire. I fell into a burning ring of fire. Went down, 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 and the flames went higher. And it burns, burns, burns. That ring of fire. That ring of fire. Hello everybody, welcome to this week's edition of Video Notes for Mr. Flugum's chemistry class. That's right folks, this is for general chemistry. So thanks for tuning in. These notes, you guys, will go on page number 13 in your science notebook. And we are going to be talking about dilutions and calculations, so finding concentrations of new or unknown solutions. So let's go ahead and get started. So just to clarify some terminology that we're going to use, first one here is dilution. So that is the process of making a solution less concentrated, right? Usually we do that just by adding more water or solvent, right? So for example here, this is how hydrochloric acid comes a lot of times, right here, in its concentrated form. We rarely use that. It's pretty nasty stuff. So a lot of times I will dilute it so that it is in a usable and not too concentrated form. The other application of what we're going to talk about today is this. It's called a titration. And we're going to do a titration as a lab next week. Basically, here's the deal. You have a solution that you don't know what its concentration is. Okay? Say it's down here in the flask. All right? So, and then we react that with a standardized or a known solution. And we precisely measure how much is added. Now, by doing that, we can figure out, because of the chemical reaction between the two, we can figure out what the concentration of the unknown solution is. Okay? Using the equation that I'm going to show you here. So let's talk about that equation. All right, here's our dilution equation, you guys. M1V1 equals M2V2. These are for two different solutions. This would be solution number 1 right here. This would be solution number 2 right here. Okay, so the product of their molarity and their volumes are going to be equal. Okay, because think about it. If you add volume to it, if you add water, right, won't the concentration go down correspondingly, right? So M here stands for molarity, right? Remember we talked about this, and if you're doing these notes ahead of time, this is molarity, okay? Remember that is the moles per liter, right? Okay, so that's the concentration of the solution, okay? The V stands for volume. Okay, so when we have the product of the molarity and volume of solution 1, it's going to be equal to the product of the molarity and volume of solution number 2. Now when we're talking about volume, okay, volume can either be in this, it can either be milliliters or liters, okay, you just have to use the same thing, right? If you use milliliters in one, it's going to be milliliters in the other one, all right? And then molarity is always M, right? Big M for molar volume, for molar. Okay? Here we go. Let's do a few example problems. All right, folks. So I hope this problem still shows up on your screen here. It's a dilution problem. Okay? And we're going to set this up in our M1V1 equals M2V2 equation. Okay? So it doesn't matter which solution we make which, as long as we match it up correctly. So I'm going to take my first solution here and make it solution number 1, where I have 250 milliliters of a 0.1 molar solution. So let's put it in here. My concentration is 0.10 molar, right? And I have 250 milliliters of it. Cool. All right, that's going to be equal to my solution number 2, which is a 1.0 molar solution. And then I want to find out how much volume I need of that in order to make my 250 milliliters of 1.1 molar. So this becomes just a simple algebra problem now, right? So here you can see I've simplified the left-hand side here, and then I have divided by the molarity over on the right hand side so I can get my volume by itself. And when I do all this math, if you notice, I kept the units in there so that they cancel out, and I get V2 is equal to 25 milliliters. So that means in order to make this solution that I want, I need to measure out 25 milliliters of my 1 molar CuSO4 solution. Okay folks, so here we have just another quick dilution problem. Again, we're going to use M1V1 equals M2V2. And we'll go ahead and set things up, right? We've got 3 molar solution, and we want to figure out what volume of that we need. So there's V1, and that's going to be equal to our 1.0 molar solution times 450 milliliters. So we'll go ahead and solve this, right? 3.0 molar times V1, if we simplify, it gives us 450 molar milliliters. And I just leave the units there, in order to kind of help you out with units. So if we divide by 3.0 molar, right, our molars cancel out, and we get V1 is equal to 150 milliliters. So we need 150 milliliters of that 3 molar H2SO4 in order to make the solution that we want. All right, so we've got a titration problem here. Like I shared with you earlier in the presentation, we are going to be doing one of these in a lab next week. And this is actually very similar to a problem that we'll deal with in the lab. Now, even though it's not a dilution, we are comparing concentrations of 2 solutions that are reacting together. And because they generally react on a 1-to-1 basis, like 1 mole to 1 mole, we can compare their concentrations. So here we go. We've got this, right? We've got solution number 1, which we don't know, right? So we know M1, right, times its volume, 29.8 milliliters. And that's equal to, we've got a solution of vitamin C, right, 25.0 milliliters, right, times 0.03 molar. By the way, that's 25.0, right? Okay, so let's simplify and solve. Okay, now that I've simplified and divided here, we can find our M1. And if you notice over here, our units nicely cancel out so that milliliters go away, and we get molar, and I get 0.025 molar iodine. So that means my iodine solution has a concentration of about 0.025 moles per liter. Well, thanks for tuning in, you guys. I hope you have a great day, and I'll see you in class on Thursday or Friday. Bye-bye.